Good morning, students. I am Manikant Mishra, Modern English School, New Area. Class 10, Chemistry, Lesson 2. Today we are going to discuss more about the base. Today we are going to discuss more about the base. Let us start with the physical properties of base. Now, if you taste the base, it is a bitter in taste. It is a bitter in taste. Feeling of touch, it is a slippery, it is a soppy to touch. Like if you take the lime water between your fingertips and if you rub it, then you will get a slippery feeling. Effect on indicators. If you pass the red litmus in a basic solution, red litmus turns blue. In a basic solution, red litmus turns blue. If you pass blue litmus in a basic solution, it has no effect. Methyl orange turns to yellow. In a basic solution, methyl orange turns to yellow. Phenolphthalein, colorless phenolphthalein turns to pink color. Colorless phenolphthalein turns to pink color. So this is about the effect on indicators in a basic solution. Now conductivity. The basic solution, aqueous solution of sodium hydroxide or aqueous solution of base. Aqueous solution of base conduct electricity due to presence of ion, due to presence of hydroxide ion or sodium ion. This is responsible for the conductance of electricity. One thing also you keep it in mind, this conductance is only and only possible when there is a water is present. Suppose if you take the solid sodium hydroxide, it will not conduct electricity. So what there is a need of aqueous solution. It means it has to dissolve in water. And as you have already studied, the solution made by dissolving in water used as a water as a solvent, then resulting solution is called aqueous solution. For that we represent AQ in a short. So role of water in deciding the basic properties is also very important. Role of water is very important in deciding the basic behavior of base. With these physical properties of a base, now let us talk about the chemical properties of base. Let us start with the chemical properties of base. So first chemical properties of base, reaction between active metal and base. Like when in aqueous solution, of concentrated aqueous solution of sodium hydroxide, if you add zinc metal, then but little amount of heat is required, otherwise rate of reaction will be very slow. You may not be able to observe whether any evaluation of hydrogen gas is taking place or not. So for that there is a need to supply the heat energy. So as you supply the heat energy, then you will be able to observe some evaluation of gas is taking place. That is a hydrogen. That can be tested by burning. Bring the burning matchstick near the mouth of the test tube. If it gives a pop sound, it means evaluation of gas is only and only hydrogen. So sodium hydroxide reacts with zinc, forms sodium zincate and hydrogen gas. Next chemical properties, reaction between base and acid. So base reacts with acid, form salt and water, and this is also called neutralization reaction. Base reacts with acid, forms salt and water. Next step, reaction between base and non-metallic oxide. Reaction between base and non-metallic oxide. Like a sodium hydroxide reacts with sulfur dioxide, that is a non-metallic oxide, form sodium sulfite plus water. So here is also, it is a salt, it is a water. So this experiment also suggests that reaction between base and non-metallic oxide, where sodium hydroxide as a base combined with non-metallic oxide, sulfur dioxide, form sodium sulfite. Sodium sulfite and water. Sodium sulfite is a salt and it is a water. This experiment also suggests that sulfur dioxide acts as an acid, because base reacts with acid, forms salt and water. Now, just in a physical properties we have already discussed the role of water in deciding the basic character. So when the base is dissolved in water, it dissociates. So just we have discussed in a physical property the role of water in deciding the basic behavior of a base. So when the water is added, then it is dissociated into ion. So water has a very important role in deciding the basic behavior of a base. This concept was extended by Arrhenius, and he tries to define the definition of base. So according to Arrhenius concept, what is a base? Base is a substance which when dissolved in water produces hydroxide ion. According to Arrhenius, base is a substance which when dissolved in water produces base. According to Arrhenius, base is a substance which when dissolved in water produces a hydroxide ion. So like NaOH plus H2O gives Na plus aqueous plus OH minus aqueous. NH4OH plus water gives NH4 plus aqueous plus OH minus aqueous. So with two examples in both the cases there is a production of OH minus ion in both, but these two are represented by different sign. Like here is a pointing towards this arrow head, single headed arrow pointing towards the product. This shows that all the sodium hydroxide at maximum extent, the sodium hydroxide dissociates into Na plus and OH minus. But the other example is NH4OH plus H2O is represented by double-headed arrow. This shows that ammonium hydroxide dissociates partially into ammonium ion and hydroxide ion. It means all the ammonium hydroxide molecules do not dissociate into ammonium ion and hydroxide ion. So based on these we can say that there is strong base and weak base. What is strong base? Base which when dissolved in water dissociate completely into their constituent ions. Bases which dissolve in water dissociate completely into ions, then such base is called strong base. As for example, sodium hydroxide, potassium hydroxide are the example of a strong base, and strong base also act as a strong electrolyte because of large number of ions are present. On the other hand, bases which when dissolved in water dissociate partially into ion. It means all the base do not dissociate completely into ions, then such a base is called weak base. One of the example of a weak base is ammonium hydroxide, magnesium hydroxide, aluminum hydroxide. These are the example of a weak base. Now when we talk about the base, it comes in our mind either oxide or hydroxide of metal or ammonium, or either of the metallic oxides or metallic hydroxide or ammonium hydroxide. But some of the oxides are soluble in water, some of the metallic oxides are soluble in water, but some of the metallic oxide do not dissolve in water. So the metallic oxide or hydroxide which is soluble in water is called alkali. What I said? Bases which are soluble in water are called alkali, and the metallic oxide which does not dissolve in water may come under the category of base but do not comes under the category of alkalis. As for example, like a sodium oxide, calcium oxide are soluble in water. The calcium oxide is a 50% soluble in water, not completely, but sodium oxide, ammonium oxide, potassium oxides are completely soluble in water, so they form alkalis. Whereas on the other hand, copper oxide, ferrous oxide, ferric oxide are insoluble in water, or solubility is very less. So these are bases, but these are not alkali. So hopefully you understood the base and alkali. Bases which are soluble in water is called alkali, and bases which are not soluble in water is only called as a base. With this, thank you. Have a nice day.